Just think about it. What kind of distribution error is having? No answer. I think here, what course I used to teach, I try to explain everything from deeper sense, so that you can answer any of the question. Generally, it is just one application of central limit theorem. So error generally happens to be normal in nature. So whenever people are calling it, and the data is noisy, that means error is associated with that data. And what error generally we are taking? We are taking error of normal Gaussian, with Gaussian distribution. Generally, we are taking. Yeah, definitely, we don't know what is the mean, and we don't know what is the variance of that. We don't know that. We need to calculate it based on that data. Okay, and based on some kind of criterion function, we can estimate those things. So while doing all those, we come across with some kind of linear model. So and that's why error in total always happens to be no Gaussian in nature. Okay, individual error. One error of the source might be what one of the source. It may come from Gaussian, exponential, or Poisson, or depends upon what kind of data you are measuring. There would be in that data set there would be various attribute. So each attribute may have different source, and based on different source, they may have different type of error kind of thing. Okay, but if you take error in totality, it would be always Gaussian in nature, or approximate Gaussian, and that one is coming from the central limit theorem. Again, you need to recall that central limit theorem. I'm not going to cover it. I have already covered there in probability and random process classes, and for ECS student, and for CSC, you may look your course, that what probability course you had taken in third or fourth semester. So tell me whether that here this panel is visible or not. I have already shared the screen. Anyone respond whether it is visible or not?
Yes, sir, it's visible.
Okay, fine. So today I will talk about distribution, a specific distribution. I'm not going to cover all the distribution. I will just cover meaningful distribution, and later I will talk about estimation of that. And first, we need to know those distributions. So there are various distributions. Simplest distribution always happens to be Gaussian distribution. Overall distribution. If you talk about distribution in totality, always that takes the form of Gaussian distribution. If the number of observation happens to be greater than equal to 32, then that sample will have an approximate normal distribution. I'm not saying that exactly normal distribution. That one is the ultimate conclusion of central limit theorem we wish to say. Okay, so I will start with Gaussian distribution, and how to see all how to play with Gaussian distribution there in here in programming, that I will talk about. One more thing, that if you talk about Gaussian distribution, univariate Gaussian distribution, that means one-dimensional data we are taking, and if you try to visualize geometrically, then we tried, if some data is distributed according to Gaussian distribution, then how we can visualize that? We can visualize it through density. How much dense they are near to mean, how much dense. If generally what is happening, the data that one is coming from the Gaussian distribution mostly happens to be very much dense near to what we call it mean. But if you go away from the mean towards tail, whether right tail or left tail, then the density will decrease, and hence the plot of density that is falling towards origin, zero, falling toward zero. That is the ultimate aim. So first we are going to plot various normal distribution. That means we will take value of x, value of data between from x-axis, and the plot will come along vertical axis. That means univariate normal. I will plot it here. So again, we need to apply here array. So in order to call array, we need to call the library and numpy. And what you do, and in last class I had already told that regarding variance, I had discussed that variance, you can define a various function without using any library. But those approaches are only meaningful those who are ultimately very good in programming, they can go for that. For that, you have to be very good in object oriented programming. So for those people, that approach is really interesting. But for other, because library, there are various library, you can go for all these kind of things. So I'm calling you again. I would like to see the plot of whatever things I'm taking. I always like to plot it. So simple. This one is the simplest plotting library. That's why I'm calling it. Now here, one more little bit what important kind of library that I'm taking. This one is also one kind of simple library that I'm taking. Scifi. Scifi is not a very advanced library. It is definitely a starting phase. All these are in a starting phase. Not generally you can get all these. So these are very common use kind of things I'm taking. So from Scifi states, there would be various functions regarding statistics. And if you go for optimization, again in Scifi, you can get optimization technique. If you are going to solve differential equation, again you can get in Scifi various term of integration and differentiation, and so solution process of differential equation you can get it. So Scifi is covering very large class of things, functions, so that you can use that in solving what kind of problem you want to solve. So in Sci-Fi, there is already what we call it norm function. Through that, you can extract PDF of Gaussian distribution or normal distribution simply. So I'm taking creating data first. First one is I have already taken library, so better is this one. I will go. I'm taking first distribution, which is very important in estimation, that we are calling it Gaussian distribution. So this I will name it Gaussian distribution or normal distribution. Gaussian distribution. That one is very much meaningful in what we call it in estimation. Then we need to create data. So x I am taking value between certain value. So there must be some starting point. So we need to start here. We can take symmetric data. Generally, Gaussian is symmetric in nature. So we are taking value of x between -6 and 6. So we have to start from -6 and we have to stop at 6. That means we are taking data from -6 to 6. But how many data we are taking between in these two numbers? Suppose we want to take 200 data. So number that we are putting it here. That means the data of x we have already taken. Now our next task is we need to plot the density, plotting the density. So density is already, that definition of density is already inherited in Scifi.stat. So that's where we are calling that library. So from here, how we can plot that? So again, for plotting purpose, simplest matplotlib I have already taken. Now here we are going to plot this one. So we need to initiate the plotting figure. That how we initiate? We initiate plot.figure, and what we need to give one identifier. So we are giving identifier, suppose 0, especially for this. Later I will take another, then I will give another identifier. So first argument it would be identifier. Second argument I am taking it as a size of the figure. So fixed size. Command name of that argument is fixed size. Fixed size. I'm using a spider. Why? Because you might be aware of that. Always I'm getting hint, because I can't say that I'm very much perfect in English. Definitely there might be some kind of syntax error. So that's why, to get over that, spider environment is really good. It always suggests, it control your mistake. So that's why this looks very fine for me. You won't commit mistake. Everything here, you are not seeing any red kind of approach. And if any sign is you observe here, that means this library you haven't called till now. This sign is saying that this you haven't called till now. So later I will call it. There is no issue. So I have already fixed the created a figure domain that would be of the size. Height would be 10, and width would be 8. So that I have already created. Now I'm going to plot the density. So PLT plot again I will use. Now here I will use the normal density function from the Scifi. So plot would be always density, plot of density. Density is always coming with respect to what we call it vertical axis, and axis taking value along the what we call it horizontal axis. So norm dot PDF, normal PDF we are taking it. So the argument is for that PDF is x, and what are other argument? So what would be other argument? It is calling, asking for argument. What are other argument in this? Okay, we need to locate the mean. So mean simple locate. We are taking mean 0, and after locating mean, we have to go left and right through a standard deviation. That means mu plus minus sigma. Sigma is a square root of sigma square. Sigma square is the variance. So that's why we need to scale and from the location of 0. How much scale we need? So a standard normal distribution, generally we are taking a standard deviation equal to 1 or variance equal to 1. A square of 1 is again 1. So that we have already fixed. It is now definition. It is, this one is talking about definition of normal distribution. Okay. Apart from that, we need further command. What command? You might have already seen that those command is talking about color, because I will plot for various what we call it various mean and standard deviation, or simply variance. Different variance and different. So that's why I need to give a command to each one. So I can, for color, you can simply use K black. For K what would be enough, or you can write completely black. Now next you have to label it. So we are labeling it. So what would be unique here through which we can label? So unique would be here. What the location of the mean? That one is at 0. And what is the scaling factor? That means how much it is spreading. So a spread, measure of a spread, always we call it variance, and a square root of that we call it a standard deviation. So a scaling will have, so we can label any Gaussian distribution or normal distribution by corresponding a standard deviation or variance. So we need to labelize it. So label again, it is talking about the command of so generally mean we are taking, and that Greek letter we denote it by mu, and mean is where? Mean is at 0. And where is the what we call it? What is the standard deviation? I can, what notation of standard deviation we are taking sigma, or correspondingly variance would be sigma square. So either you can write a standard deviation or variance, but if you're writing a standard deviation, it looks fine. Why? Because a standard deviation and the mean both are having the same unit, but variance is having a square unit. So you can always proceed with a standard deviation. That one is the sigma. So there is no issue with command. If you want to look into the plot, you can see it here. It will come something like this. Yeah, it is coming single plot we did, but we'll plot for various mean and what we call it variance, various variance and various mean. And one more thing, whether plot is visible or not. Anyone?
Visible.
Is it, yes, is it visible or not?
Yes, sir.
Yes, sir.
So can you further beautify it? How you can beautify? So better to have a closed loop, you always put what? Grid. It will give a closed view of what we call it values that you can identify. So here mean is here, this is the mean of this one, and this is the what we call it. If you go, you can go right one unit of this one, you will come here. That one is talking about right scaling, that is talking about variability. And data we have taken between -6 to 6. If you raise the range, then it will go, definitely this will tail will approach to what it will asymptotic to this horizontal axis if you raise the range of x. Now further you can do one more thing, that means you have to call one more thing legend. So it will bring, you can see it here, mu equal to 0, sigma equal to 1. This label came as a legend. So through legend function you can call those things. You can see it here like this way. So everything would become, now we will plot another uh, Gaussian or normal distribution with different mean and variance. So just I'm copying this again, and I will change here location. Suppose I'm taking mean 1 and increasing the standard deviation as well, 1.5, little bit more spreading. So and hence we need to change the color as well. So better I will take color red or blue or something like whatever you want, yellow, anything you can take it. So here our what location is 1, that means mean location is 1, and standard deviation is 1.5. You can look it in here. So red, this one you can observe. So from the graph you can easily observe that it is more spreaded. This red graph, the red plot, it is more spreaded. Okay, but one more thing, you can see that mean is shifted towards right. It is not symmetric with respect to origins. So here, okay, uh, it is not symmetric with respect to origin. This also you can see that. One more thing we can add it here, we can levelize the axes as well. So how can we level axis? So x-axis we level it through x level, and here what along x-axis we are taking the value of x. So again in the, okay, and along y-axis we are taking value of the density. So y, we label y-axis. You won't commit any mistake if you are using this platform, because always you are getting proper 8K. So and if you are committing any mistake, the red sign would be there. So don't worry about any mistakes and take mistake if we are using a spider. So here further things you will say that density is coming along, it is along vertical axis, and axis value of x is taking along. So if further if I talk about intuitive approach of x, then height of x is what density is very high here. For black, density is very high here near origin. That means what we talk about, what is meaning of that? So near x equal to 0, that origin or mean, there are the data is condensed, very high amount data. So then that's what the density very near to each other, it means density is very high. If you take data near about -6, -4, then those data are very much spreaded. That means density is very less. So that's where density height is, that height is very less here. Here height is approximately to 0. Also you can see it here, because here density of data is very less. So that's where height of the density is approximately 0. So that is the intuitive meaning of normal density, normal distribution, we can say it. So it is all about, if someone is willing to come with another mean and variance, a standard deviation, you can plot further. Just I am copying it again, just to save the time. So if you want to take mean -1 negative towards, you want to shift mean towards what, left. So and variance you can take 1 or 1.5, depends upon whatever. So that means, and also you need to change the color, take color to make it different. Change the color, yellow, we are taking yellow. So here mean is what, -1, and variance, standard deviation we have taken 1. So again you can see it here, yellow pen, it is shifted right. So all the legend are coming here. These are labels, you can see it here. A yellow one is this one, it is having mean -1 and standard deviation 1, and black one is having mean mu, standard deviation 1, and the red one is having mean 1 and standard deviation, what we call it, standard deviation 1.5. So it is very much clear from the graph. You can see that if you increase the variance, the height will decrease, because overall area have to be what 1 in order to satisfy the normalizing condition. So it is very much simple that if you increase the variance or increase the standard deviation, your height will decrease. If you reduce the variance or standard deviation, your height will increase. So that is the simple. And if you just decrease the variance always it would be a non-negative quantity. That means greater than or equal to 0. And hence we can say that standard deviation is also non-negative number, and hence that would be also greater than or equal to 0. So if you take a standard deviation approx 0, then normal distribution becomes direct delta function. That means it is very high, taking very high value at a single point, and the rest of the point it is 0, direct delta distribution that we are calling it. So you can say that direct delta distribution is what it is a special kind of limiting version of Gaussian distribution, where x is approaching to what we can say that uh, uh, simply we can make it to approaching to 0, something like that. We can say that like in that perspective. So it is so that is the there is a specific definition that you can define direct delta distribution with the help of Gaussian distribution. You can find those literature. So it is very much related with it, that. So one, I told that generally whatever total error you are taking, so error is having always either Gaussian distribution or normal distribution, or approximate Gaussian distribution or normal distribution. So that's why I'm discussing this one, because always we will proceed with if someone is saying that the data is noisy, that means definitely some kind of Gaussian distribution would be involved there in that linear model. So that's why we are coming with this. Now next, what we do, actually we are always minimizing a square of error. So error is distributed in a Gaussian fashion. Now we are talking here a square of error. Now anyone would you like to suggest, if you are taking error as a Gaussian, then after you're summing the Gaussian and squaring it, after squaring and summing the Gaussian, then what kind of distribution you will get? Have you heard such kind of distribution, which is a square of sum of a square of normal distribution or Gaussian distribution? So what is name of such kind of distribution? Have you heard that any distribution which is sum of a square of normal distribution? Here error is distributed normally, the total error. Okay. Now I'm talking about that criterion function, or that a square loss function we are talking about. So here it is dealing with a square of sum of a square of normal, because we would have various samples. So with respect to each sample, we have to calculate a square of error, and we have to sum in order to get accumulate all those samples. So that's why we are dealing with sum of a square of normal distribution. What is the name of that distribution? Anyone? Do you have idea?
So is it chi-square?
Yeah, very nice. Chi-square distribution. So we are talking about chi-square distribution. So when you are dealing with what we call it that criterion function, so always you deal with what chi-square distribution. So you need to know, right? So next we will discuss about chi-square distribution. So if you want to understand, so all these distribution I am calling it because all these are having very important role in order to understand linear model or that estimation things. So whenever I will define any kind of model structure, so those would have any of these pattern, and there we will try to estimate the corresponding parameter. The second distribution we will take it chi-square. So very nice. You can answer through also you can Google it. Actually, just try to answer things and try to relate things. Why we are studying? It is your right to know why I am studying particular things in any course. Okay, so we will talk about the chi-square. So I am writing in short 2 mean for a square. So chi-square distribution we'll talk about. And later I will talk about the estimation process. Right now, just I am introducing. So this is distribution number 2, important distribution for linear model 2. And here again I will talk. Actually, I if I am running all these in the same file, then there is no need to call same library various time. But definitely here you can say that you see that I'm running the command cell wise. It is not like not that I'm running all the command in total together. So I'm running cell wise. So that's why I used to call it. So I'm calling individually. Say I'm importing again numpy. Then again I will introduce plotting library matplotlib. You can go for plotly. Plotly is also very interesting kind of library. Then from Scifi, again all these function what I am using, there is advanced library that we are calling it statistics model. From there you can call it. There are, all those are there. There is no issue. You can call. But I like Scifi a lot. It is very much common kind of library. So here from Scifi, we will talk about Chisquare. We will call it import Scifi. So simple name is Chai2. Chai2, it is, yeah, we are right. Chai2 is there in Scifi estate. Okay, now then after we will create data. So we are creating data. Definitely, it is a one kind of fake data. It is not. We are not going for measurement, actual field measurement. I am creating it. So it is a. So in another way also you can call it. It is a fake data. So line of space. So again, I can take. Okay. I need to know starting. So starting of this, if I talk about Chi-square, so what would be a starting? Anyone? X, where from where X will start? Anyone would like to comment what would be the starting of this X value, this data, starting value? Anyone that, because someone answered nicely that if you sum a square of normal, then that one is having Chi-square distribution. Then very nice. If you are squaring something, then definitely you will have idea of the smallest value of X. What would be the smallest value of X? Any idea?
0.
Yeah, very nice. It would be 0. And then a stop, you can go up to wherever you want to go. You can go. So generally in normal, I had taken what 6. You can go up to 36. Again, if you are taking 36, then there is a limitation with my laptop. It won't go 36 length, and otherwise that size would be very small. Size would be very small. So I won't call. I will go to up to 36. I will limit it to 10 or 20 or something like that. 20, even if I go for 20, then that again there is a limitation with my laptop. Okay, so I want to go for I will go for 10. Okay. Now next, what we do? Plot the density. Everything is there in what in online platform. You can get all those things, but main thing is understanding. You need to understand all these. So again, we need to start with the figure. We have to initiate the figure. So we are initiating the figure. Figure. And here it would be that one identifier for normal distribution we had already taken 0. For this, we will take another identifier, call it 1. And size, we will take the same size. You can go for different size, there is no issue. Size, I am taking it. Mostly I'm taking 10 by 8, so that's why I will stick with that. And after that, I will plot X versus. Here I have called it Chi-square. Always int is coming, but I have to plot the PDF. So I want to go for just PDF. Now, what is a common thing in Chi-square? What is important thing? There is one very important concept is associated with Chi-square that we are calling it degree of freedom. degree of freedom, that means how many normal, how many sum, what is the sum size. So that one is defining the degree of freedom. If you are taking degree of freedom 1, that means you are taking only one normal observation and squaring it, then it will what? So in that case, chi square would be just a square of that normal. Suppose z is the normal, so chi square would be what? Z square. If you take degree 2, then what would be chi square? It would be x1 square plus x2 square. X1 square plus x2 square. So such kind of things you can keep on going for further. So that how many degree, that means how many normal distribution you are taking, that one is defining degree of what freedom. So simply we are calling it degree of freedom. Now we are going to plot it for this one, a single degree of freedom. That means what does it? It is talking about single normal distribution we have taken. So we need to give a color. If you want to give a color, it's fine. Otherwise, there is no issue. Right now we are giving a simple color, that black, or simply you can write it K. Short form is K. And afterward, we need to labelize it. So for why? Because we are taking various what we call it, various square PDF. Various PDF you will take for various degree of freedom. So we need to labelize it. So k equal to 1, or simply k equal to 1, we can call it like this way. And what we do, you can take it here like this way if you want to see the plot. So simple, you can see that there is no negative things. Okay, there is no negative things, only positive. It is positive things. So it is plot of, simply you can say that x square, the distribution, that x is a normal distribution. After doing the squaring, this is the PDF of x square, you can see it here. So we will go further, and apart from that we need to introduce that label as well. X label, it would be same. X label, x axis, value of x we are taking. Y label, it would be what we call it, a density. Density, and then we need to put legend. Then also we need to put grid for better visualization. Okay. Now what we do here, I will use for loop. Again, things are fine. There is no issue. Things are fine. Level, you might have already seen that k equal to 1, it is coming. Now we will run for loop in order to take various degree of freedom. So we are going to take various degree of freedom from for loop. So the index I, it will range from some value in range. I think suppose we are taking range 0, we can't take degree of freedom. So what we will do, we can take 1 degree of freedom we had already taken. So we will go from 2 to 7. And then I can copy all these. Okay, so here degree of freedom, in place of that I will call it I. Now there would be issue with color. How we can define color? So color, we can define it. We'll leave it this color. It will be handled later. So we won't define color, but we can control the label in the loop. Otherwise, you can introduce the color. You can define one list of color, and you can run that index from the list as well in order to associate the color. There is no issue. There are various commands. So better I want to go for that approach. So I will here just go for indexing or labeling of that. So how we will label it? So we will label it through a string, that st, short form is what, str, a string, and it is coming from index I. It is something like that. Okay. and I think there is no issue. You can see it here. So everything looks fine. Now you can check it here. There would be no any issue. So, but problem would be that here fix all these here along with the loop, so that this will also come according to or simply noise. Any question? You can see all the plot. Now this figure doesn't look good. The value of y, the density change going only this that this chi-square distribution with degree of freedom 1, that one is taking value up to 1.75, other are taking maximum value 0.5. So what we do, we have to limit to fix the limit y limit. So PLP dot y limit, we need to fix it. So suppose we are fixing it to 0 to 0.5, because we can see that the second largest is getting 0.5. So that's why we are limiting out. Now the figure would be 5. So you can see it is fine. So all these you have to keep on doing smartly. After looking into that plot, you can do all those manipulations. Those are part of this math plotting. There are various approaches. It is not a single approach. There are various approaches to do plotting. So tell me, what is the next distribution which is important in linear model? First is normal distribution or Gaussian distribution. Second is chi-square distribution. What is the third distribution which is very much essential in linear model? Anyone? Till now I got very good answer. Two answer. Now I'm asking for third distribution. What is the third distribution which is we will estimate in this linear model? And then that one is playing very meaningful concept there in linear model. What is the third distribution? Anyone? Have you heard? Even with that distribution, there is a story. You people are a student, so I think you should know that story. What is the third important distribution in linear model? Anyone would like to comment over it? You all are a student, so I think you should aware of that. I am giving enough hint. Any idea? No. It is a
No,
student.
sir.
It is a student distribution. Name of that distribution itself is a student distribution. Or you can say that another name is T distribution. So it is, you can say that it is truncated normal distribution. Truncated. Normal distribution always go up to infinity, right infinity and left in infinity. But T distribution is not, it is not going to infinity. And that person actually, he was not willing to publish his name. So he came with that idea of name of T distribution or a student distribution. So third distribution, important distribution is a student distribution, or simply you can say that P distribution, because it is talking about P statistics of what we call it estimation, whatever estimator we are taking. So T statistic. So again, that one is one kind of what we call it characterization of estimator. So third, we will talk about P distribution, or you can say that P or student distribution. Both are same. This one, this one is really interesting. You can Google the story of this one, you will get it. I don't want to cover a lot. I don't know the name of that person, and that person just come up with name of student distribution. So we need to again recall it numpy as np. We are importing matplotlib pyplot as PLP. Now again from this Scifi, we will call P distribution or student distribution. import. Here, one thing is guarantee, you won't commit mistake. If you are going in a very proper way, you won't commit mistake. So we are creating fake data. And p dot line 5 space. So here you have to be very much attentive. So what would be a starting value of x, and what would be then what would be a starting value? I told that T distribution is what truncated version of Gaussian distribution. So you can take a symmetric start. There is no issue. So like Gaussian. So you can take -6 to 6 or -5 to 5, whatever you want to, and you have to stop. It is what truncated Gaussian, you can say that. And how many point we are willing to take? 200. That one is a number. So that's it. Now we will plot the density. Plotting the density. So we can do here. So if someone is asking how we define T distribution, so what you do take a standard distribution, a standard normal distribution. Generally, the notation of a standard normal distribution is Z, and divide that by square root of what chi-square. Ratio of chi-square with corresponding degree of freedom. Corresponding degree of freedom. So it is one kind of just it is idea is coming from that one is giving idea of T statistics. So here and there is no writing option directly. A square and many things is needed. So I am going to plot first, and this would be last distribution of today's class. Apart from that, only 3 distribution will come along in this course. So my suggestion to everyone, just understand all these, whatever I discuss, and keep on doing practice, and you will feel easy in this course. If you are having very good approach, understanding of this distribution, then definitely you will feel very easy. Even I will definitely take different kind of error, distribution of error, like individual distribution of individual error, like sometime Poisson or something else. But don't worry. So that would be not an issue. Generally, that will finally converge to Gaussian distribution. So that is the story. And just let me finish this tutorial by plotting it. Yeah. So we need to plot it. So what I will do, directly I will take for loop. I will do looping with respect to, I will define degree in a list, and through loop I will call each entries of that loop. Okay, so I want to individual plot. I will do here, I will run a for loop. For loop I in, so I will give a range for this one. So range, suppose we are taking, I is taking range 0 to 5, and within that loop we are plotting a PLT dot plot. PLT dot plot, and X versus T distribution, T dot PDF. And here X, definitely first argument would be X. Next argument that would come from the degree of freedom. Because the T distribution is defined as a ratio of standard normal distribution and the square root of the what we call it ratio of chi-square distribution with number of degree of freedom. So degree of freedom we are defining as a list-wise. So here, because in order to run, so suppose you can take degree of freedom 1, 2, 3, 4. We have 0 to 5. That means 5 quantity. 0, 1, 2, 3, 4. Okay, 5 is not included. So we need to take 5 degree of freedom. 1, 2, 3, 4, or 3 also. 3, 5. Next last one, take fifth one, take 100. 100. Okay, fine. So here, this is the degree of freedom, and here we are calling highest index. So there is no issue. Now after that, we will labelize it. I'm not putting color. Color, let it decide by default. So here, K equal to, it would come from a string. That leads to what we are doing. A string of, so we are converting that list into a string. So list is 1, and there is a gap now. 2, 3, 5, and 100, and we are putting indexing here. There is no mistake. It is perfectly fine, because otherwise we might have read. So after that, what we do? So I don't go again. I will copy all these. Okay. Let's run this. So from the plot, you can see that abrupt truncation at the end at -5. In left hand side and right hand side, you can observe that there is no tail. Tail kind of situation would be not there. So it always looks what Gaussian kind of things, but it is in truncated version. But remember that it is defined in different fashion. And this distribution, we are calling it a student distribution or T distribution. Okay, it is already above 45.